Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Let us have a final exam and solve a final exam, okay, as a practice about the subject. So this is the final exam on December 2021. Find the absolute maximum and minimum values of the function f of x equals x squared minus 4 to the power 3 on the interval 0 and 3. If you remember, to find the absolute maximum and minimum on an interval, we need to find the local maximum and minimum. To find the local maximum and minimum, I find the derivative. So the derivative of f is, using the chain rule, is 3 times x squared minus 4 to the power 2 times the derivative of x squared minus 4, which is 2x. So the derivative is 3 times 2, 6x, times x squared minus 4 to the power 2. Now to find the critical numbers, I need to put the derivative equals to set the derivative equals to 0 and find the zeros of f prime. So here I have x could be 0. This is one solution. And the other solution, that x squared minus 4 to the power 2 is 0. But then x squared minus 4 has to be 0. And then x squared is 4. And then x is positive or negative square root of 4, which is 2. So there are three critical numbers, negative 2, 0, and 2. And all of these numbers belong to the domain of f because the domain of f is the set of all real numbers. This is a polynomial. So how to find out now the local maximum and the local minimum? These are mm, these are the critical numbers, and any one of them could be local maximum or local minimum. I can find exactly each one of them, but notice that negative 2 does not belong to the interval from 0 to 3. So you'll talk about 0 and 2 only. Uh, to find the absolute maximum and minimum, we make a table now, x and f of x, and we put the endpoints of the interval 0 and 3 and the critical numbers inside this interval, which is 0 and 2. 0 is already there. So I have three numbers, the critical numbers inside 0, 3, and the endpoints of the interval. Now, replace x by 0 here. F of 0 would be negative 4 to the power 3, and that's negative 64. F of 2, 2 to the power 2 is 4, 4 minus 4 is 0 to the power 3. F of 3, 3 to the power 2 is 9, 9 minus 4 is 5, 5 to the power 3 is 125. So absolute maximum is 125, and it is f of 3. And absolute minimum is f of 0, which is negative 64. So the absolute minimum is negative 64, and the absolute maximum is is 125. So that's the answer. Find the absolute maximum and minimum. Okay. Verify that the function satisfies the three hypotheses of Rolle's theorem on the interval from 0 to 9. If you remember, Rolle's theorem has three conditions or three hypotheses. First one, that the function f of x is continuous on the closed interval 0 and 9. And that's true because if you want, you can say that since the domain of f, you write the domain of f. What is the domain of f? You have a square root, so x has to be greater than or equal to 0. So the domain is from 0 to infinity, and 0, 9 is part of 0 to infinity. So the function is continuous from 0 to 9. Also, you can say the second hypothesis, f of x is differentiable on the open interval 0, 9. And the reason, because find f prime. What is f prime of x? F prime, the derivative of square root of x is 1 over 2 square root of x, and the derivative of negative 1 over 3x is negative 1 over 3. This is f prime. What is the domain of f prime? Again, we have square root of x. X has to be greater than or equal to 0, but it cannot be equal here to 0 because the denominator will be 0. So the domain of f prime is from 0 to infinity open, and 0 to 9 open is part of 0 to infinity. So f is differentiable on this. The third condition, I have to make sure that f of 0 equals f of 9. That's the third hypothesis of the rules theorem. F of 0 is square root of 0 minus 1 over 3 times 0, so that's 0. And f of 9 is square root of 9, which is 3 minus 1 over 3 times 9, so that's minus 3. So that's also 0. So f of 0 equals f of 9. So the three hypotheses are satisfied. Then by rules theorem, okay, by rules theorem, there exists a number c in the open interval 0, 9 such that f prime of c is equal to 0. This is the statement of the rules theorem. F prime, this is f prime of x. So f prime of c would be 1 over 2 square root of c minus 1 over 3, and this should be 0. When I take 1 over 3 to the other side, and then I can find the reciprocal, or if 1 equals 1, these are two equal fractions, the numerator equals to the numerator, so the denominator has to be equal to the denominator. This means that square root of c is equal to 3 over 2, and this means that c is 3 over 2 squared. Okay, to get rid of the square root, we raise both sides to the power 2. So c is 9 over 4. 9 over 4 is 2.5. Okay, so it belongs to the interval, the open interval 0, 9. So that's the number C guaranteed by the rules theorem. Two cars start moving from the same point. One travels south. Let me say that this is the first car and it travels south. So the distance, let us call the distance that this car travels x, for example, at 35 kilometer per hour. So this is the change of x. So dx by dt is 35 kilometer per hour. The other travels west. Okay, so let me write this in the other side. So dx by dt is 35. Now the other car travels west. Let me call the distance y, the distance traveled by this car, by the second car, at 50 kilometer. So this distance changes with respect to time by 50 kilometers per hour. Okay. At what rate is the distance between the cars increasing? This is the distance between the two cars. Okay. And if this car is here and this car is here now, it's the distance is increasing. Okay. Let me call the distance z. So what is the relation between zx and y? Because this is a right triangle. So the relation z square equals x square plus y square from Pythagorean theorem. At what rate is the distance between the cars increasing? So he is asking about dz by dt. Okay. what is dz by dt. And what is dz by dt 2 hours later? Okay, 2 hours later. What happens 2 hours later? Well, 2 hours later means x would be the distance traveled by the first car after 2 hours would be 35 times 2. So it would be 70 because the first car travels 35 kilometer per hour. And y, the distance traveled by the second car after 2 hours would be 50 times 2, and that's 100. So what would be the distance? So he is asking about dz by dt when x is 70 and when y is 100. And I can find even z at that time. Z at that time would be the square root of 7 square plus 100 square. Okay. And if I use the calculator, 7 square plus 100 square is 149,000 under the square root. The square root of this number is 10 square root of 49. I can write it like this or like this. Okay. So this is z after 2 hours. Now, how to find dz by dt? I find the derivative of this equation. The derivative of 2z with respect to t is 2 times z times dz by dt. Derivative of x squared is 2x times dx by dt. This is using the chain rule. Derivative of y squared is 2y times dy by dt. Well, I have 2 every term in every term. So I can just divide all the terms by 2 and get rid of the 2. And now z is 10 square root of 149. dz by dt is required. X is 70. dx by dt is given, it is 35. Y is 100 after 2 hours. dy by dt is given, which is 50. So dz by dt would be equal to 70 times 35 plus 100 times 50. That's 7,450 over 10 square root of 149. And I can approximate this number because it is a rational uh, and it is an irrational number. So it is equal to, exactly equal to 5 times square root of 49 irrational number, and it's approximately equal to 61.03 kilometer, if you like, per hour. This is dz by dt. This is the rate in which the distance is increasing, 61 kilometer per hour. Verify that 2 sinh x cosh x equals sinh 2x. Well, if you remember, the definition of sinh x is e to the power x minus e to the power negative x over 2. And the definition of cosh x is e to the power x plus e to the power negative x over 2. And sinh 2x would be, I replace x by 2x in the definition of sinh. So it would be e to the power 2x minus e to the power negative 2x over 2. So let me start by the left-hand side. The left-hand side, 2 times sinh. Sinh is ex minus e to the power negative x over 2 times cosh, which is e to the power x plus e to the power negative x over 2. Now, if I multiply, this 2 will cancel with this 2, and now I multiply this times this. So I have e to the power x minus e to the power negative x times e to the power x plus e to the power negative x over 2. 2 times 1. And this would be equal to, now if you multiply, you get this is u minus v times u plus v. So difference of two squares. So you get e to the power x squared, which is e to the power 2x minus e to the power negative x all squared, or negative 2x over 2. And this is equal to sinh 2x, and this is the right hand side. So this is the proof. Find the intervals on which this function is increasing or decreasing. To find the intervals on which the function is increasing or decreasing, I need to find the critical numbers and the first derivative. So let us find the first derivative. G prime of x would be, this is a product, I use the product rule, 2x times e to the power negative x plus x squared times the derivative of e to the power negative x is e to the power negative x times negative 1. Now I can take x e to the power negative x as a common factor. I'll have 2 minus x. So this is g prime. Now to find the critical numbers, I put g prime equals to 0. Then x is 2. This is the 0 of 2 minus x, or x is 0, the 0 of x. E to the power negative x will never be 0. So I have two critical numbers. So these are the critical numbers. To find the intervals of increasing and decreasing, I put them on the number line. Notice that g of x is x squared over ex. And e to the power x is never 0. This means the domain of G is all real numbers. And these numbers belong to the domain, so they are critical numbers. So we make the table. This is 0 and this is 2, okay? And check the sign of G prime and then find out where G is increasing and decreasing. If I choose a number greater than 2, 3, this would be negative. 2 minus 3 is negative. X would be positive. So e to the power negative x is always positive. I don't have a problem with it. So the sign is negative. From 0 to 2, choose 1, for example. 2 minus 1 is positive, x is positive, so this is positive. Negative 1, 2 minus minus 1 would be positive, but this one, x, would be negative, so I have a negative sign here. So decreasing, increasing, decreasing. So the function is increasing on the interval from 0 to 2. And it is decreasing on the intervals from negative infinity to 0, union from 2 to infinity. So this is the increasing and decreasing. Find the local maximum and local minimum. I can see here that the local maximum is f of 2. So local maximum is f of 2. And I can find the answer. F of 2 is 4 e to the power negative 2. And local minimum is f of 0. And 0, if g of 0 would be 0 over e to the power x, that would be 0. So let me change this to g because the function is called g of x, not f of x. All right, find the intervals of concavity and inflection points. To do that, I need to find g prime of x, g double prime. So this is g prime, okay? I'll use this definition. I have product of three functions. So I will use the product rule. The derivative of x is 1. So I have e to the power negative x times 2 minus x plus x times derivative of e to the power negative x is e to the power negative x times negative 1. So I'll make this negative times 2 minus x plus x times e to the power negative x times the derivative of 2 minus x, which is negative 1. So again, this would be negative. So this is g double prime. Any common factor, e to the power negative x is a common factor. Let us take it out. I have here 2 minus x. I have here minus x times 2 minus x. So it would be minus x times 2. That's minus 2x. And minus x times minus x, that's plus x squared. And I have here minus x. So g double prime is e to the power negative x times I have x squared, okay, minus 2x minus x minus x minus 4x plus 2. So this is g double prime, okay? And now to find the zero, I need to solve this equation. The zeros of g double prime, e to the power negative x is never zero. So x squared minus 4x plus 2 would be zero. I need to solve it. It cannot be factored. You can use the calculator or just the quadratic formula. Negative b, this is b, so negative b is 4, plus or minus square root of b squared, which is 16, minus 4 times a times c, that's 8, over 2a, that's 2. So it's 4 plus or minus square root of 8, 16 minus 8, and this is 2 square root of 2 over 2. 4 over 2 is 2. 2 square root of 2 over 2 is square root of 2. So these are the two zeros of g double prime. So let us make a table. This is 2 minus square root of 2, and this is 2 plus square root of 2. And let us check the signs of g double prime. 2 plus square root of 2, this is 1.4, so it's 3.4. Let us take 10, for example. Okay, a number greater than this. Put it in g double prime. Well, e to the power negative x is always positive. I have no problem with it. Anyway, I know that this is x squared. So between the zeros, the sign would be opposite to the sign of x squared. So the sign here would be negative, and here would be positive. So here the function concave up, concave down, concave up. So concave up would be from negative infinity to 2 minus square root of 2 union from 2 plus square root of 2 to infinity, and concave down from 2 minus square root of 2 to 2 plus square root of 2. The inflection points would be 2 minus square root of 2 and g of 2 minus square root of 2. You can just write g of 2 minus square root of 2, or you can find it, okay? I'll just write g of 2 minus square root of 2. And the second uh, inflection point is 2 plus square root of 2, and here g of 2 plus square root of 2. These are the two inflection points, and these are the intervals of concavity. Find all the numbers at which this function is discontinuous. The function is discontinuous when it is not defined. Okay, so what is the domain of f? To find the domain of f, well, this is a rational, I mean a fraction. So for a fraction, I have problem with the denominator being 0. So this function will be discontinuous when the denominator is 0. So let us solve this equation. E3x minus 4 equals to 0. So E3x equals to 4. And to solve this equation, I apply ln to both sides, and ln cancels E. So 3x is equal to ln 4, which means x is ln 4 over 3. So this is the 0 of the denominator, and this is the number at which the function is discontinuous. So f of x is discontinuous at x equals ln 4 over 3. And it is continuous everywhere else, all real numbers except this number. What is the minimum vertical distance between these two parabolas? Okay, I'll sketch the graph to help me solve the problem. X squared plus 2, I know the graph of this parabola it is the same, y equals x squared translated 2 units up. This one, let me write it negative x squared plus x. Okay, I can find the vertex h is negative b over 2a. B is 1, a is negative 1, so 2a would be negative 2. So h is half. K would be negative 1 over 4 plus half, and that's 1 over 4. So the vertex of this parabola would be half and 1 over 4. So if this is 1 half and 1 over 4 somewhere here, and if I find the x-intercepts, I just put x minus x squared equals to 0. This means x times 1 minus x is 0. So either x is 0 or x is 1. So this is the graph of this parabola. We need the minimum vertical distance between these two parabolas. Vertical distance. So this is a vertical distance between these 2 points. I need the minimum vertical distance. Okay. So if I call this distance d, distance is d, the vertical distance, if I call it d, how to find the vertical distance? Okay, I have here a point xy and here a point xy, the same x, but y is changing, so it is the difference change in y. Okay, y of the first equation, which is x squared plus 2, the first parabola, minus the y of the second parabola, the parabola below, which is x minus x squared. So this is the distance. Okay, let me call it f of x. So it is x squared plus 2 minus x plus x squared. So it is 2x squared minus x plus 2. This function represents the vertical distance between the two parabolas. To find the minimum vertical distance, he means minimize this function. To minimize this function, I find the derivative. The derivative is 4x minus 1. And then the critical numbers, I put it equals to 0. X would be 1 over 4. And if I find f double prime of x, if double prime would be 4 and it is always positive, this means that I have a local minimum, but it would be an absolute minimum because there is only one at the absolute minimum, because there is only one critical number. The absolute minimum would be f of 1 over 4. And f of 1 over 4, this is f of x. So I can find f of 1 over 4. It is 2 times 1 over 4 squared. Okay. Then minus 1 over 4 plus 2. The answer is 15 over 8. So that's the absolute minimum. So the answer to the question, the minimum vertical distance is 15 over 8. That's the minimum vertical distance between the two parabolas. Calculate y prime. Well, y prime, this is a product rule. The derivative of x squared is 2x times sine pi x plus x squared times derivative of sine pi x is cosine pi x times the derivative of pi x, which is pi. So I can just write it as 2x sine pi x plus pi x squared cosine pi x. Ln sine inverse, derivative of ln is 1 over sine inverse x times the derivative of sine inverse, which is 1 over square root of 1 minus x squared. So I can just write it like this. Derivative of hyperbolic tan. The derivative of hyperbolic tan is hyperbolic secant squared times the derivative of e to the power 3x times the derivative of 3x. So I can just write the answer like this. Now here, I'll use the implicit differentiation to find y prime. So derivative of x squared is 2x. This is product. Derivative of x is 1. Derivative of y is y prime. Derivative of y squared is 2y times y prime. And then the terms, I keep 2x plus y in this side. And I'll take xy prime to this side, to the right hand side. And then I will take y prime as a common factor. I have 2y minus x, and in the other side I have 2x plus y, and then y prime would be 2x plus y over 2y minus x. Find the equation of the tangent line to this curve at the point 0, 2. Well, the equation of the tangent line would be y minus 2 equals y prime. The slope is y prime at 0 times x minus 0. So I need to find y prime at 0. What is y prime? To find y prime, I'll use the formula derivative of 1 over u is negative u prime over u square. Derivative of 1 over x is negative 1 over x square, but chain rule u prime. 2 is just a number constant. You keep it, you don't do anything with it. So it would be negative 2 times u prime. What is the derivative of 1 minus 3x? It's negative 3 over 1 minus 3x to the power 2. So the derivative is 6 over 1 minus 3x to the power 2. So y prime at 0, I replace x by 0, so I'll have 1 square, which is 1. 6 over 1 is 6. So the equation is y minus 2 equals 6x. That's it. You can't leave it like this, or you can write it 6x plus 2. This is the equation of the tangent line. Evaluate the limits. If I replace x by 1, ln 1 is 0. Sine 0, pi times 0 is 0. Sine 0 is 0. So I use L'Hopital's rule. Derivative of ln x is 1 over x. Derivative of sine pi x is cosine pi x times the derivative of pi x, which is pi. So this is in fact 1 over x. X, I can bring it down. So I have pi times x times cosine pi x. And now let me replace x by 1. So I'll have 1 over pi, x is 1, cosine 1 times pi, cosine pi is negative 1. So the answer is negative 1 over pi. If I replace x by infinity here, I'll have infinity squared, that's infinity. E to the power negative infinity is 0. When I have infinity times 0, I should write one of the functions below. And e to the power negative x, I can simply write it e to the power 2x in the denominator. So now if I replace x by infinity, I'll have infinity over infinity. So I can use L'Hopital's rule. Derivative of x squared is 2x. Derivative of e to the power 2x is e to the power 2x times 2. Replace x by infinity again, I'll have infinity over infinity. So I can use L'Hopital's rule again. Derivative of 2x is 2. Derivative of e to the power 2x is e to the power 2x times 2. But there is another 2 here, so times 4. Replace x by infinity, e to the power infinity is infinity, 4 times infinity is infinity, 2 over infinity is 0. So the limit is 0. If I replace x by 1, 1 minus 1 is 0, ln 0 is negative infinity, minus 1 minus 1 is 0, ln 0 positive is negative infinity. So this will give you negative infinity plus infinity. And this is indeterminate form. So what to do with it? I will write it len x to the power 7 minus 1 over x to the power 5 minus 1 using the properties of logarithmic functions. And now len is continuous function on its domain. So at one positive, it's continuous. So I can put the limit inside the len. And now if I replace x by 1, I'll have 1 minus 1, 0 over 1 minus 1, 0. So this is 0 over 0. So I can use L'Hopital's formula. I have the len outside. Derivative of x to the power 7 is 7x to the power 6. Derivative of 1 is 0. Derivative of x to the power 5 is 5x to the power 4. Now if I replace x by 1, I can cancel this. But immediately if I replace x by 1, I'll get 7 over 5. So the answer is len 7 over 5. That's the limit. 1 minus 0 is 1. 1 over 0 is infinity. So this is indeterminate power. What to do? We call y equals 1 minus 3x to the power 1 over x. Then we apply len to both sides. And when I apply len here, I can take 1 over x out using the properties of the logarithms. And now I find the limit of len y when x approaches 0 from the right. And len y is 1 over x. Let me write it len 1 minus 3x over x. Can just write it like this. If I replace x by 0, len 1 is 0 over 0. So I have 0 over 0. So I can use L'Hopital's formula. The derivative of len 1 minus 3x. Derivative of x is 1. So that's good. The derivative of len 1 minus 3x would be 1 over 1 minus 3x times the derivative of 1 minus 3x, which is negative 3. So I can write negative 3 here and over 1, so I don't have to write over 1. Now replace x by 0. If you replace x by 0, you get negative 3. So this means that len y goes to negative 3. If I raise both sides to the base e, then y goes to e to the power negative 3. So the limit of x when x approaches 0 from the right of this function is just e to the power negative 3. The graph of a function f is shown. Find the numbers at which f is not differentiable. Well, f is not differentiable at this number because it's not continuous. So negative 4. At negative 1, I have a corner, sharp corner. So it's not differentiable at negative 1. At 2, I have an asymptote, okay, discontinuity also. So at 2, the function is not differentiable. So these are the three numbers. I have no problem at 4, okay. At 5, I could have, at 5, yeah, there could be a vertical tangent, okay. So there is a vertical tangent here at 5. So also at 5, it is not differentiable. Find the numbers at which f is not continuous. It's not continuous at negative 4 and 2, discontinuity, but it's continuous at 5 and negative 1. Find the vertical asymptotes, if any. Well, there is a vertical asymptote at 2. So the equation of the vertical asymptote is x equals 2. Sketch the graph of a function that satisfies all of the following. F prime is positive for x less than 0. This means that the function is increasing increasing for x less than 0. Okay. And decreasing for x greater than 0. Okay. If double prime greater than 0 for all real numbers. So the function is concave up. Here it's increasing, here it's decreasing. Okay. Limit f of x when x approaches 0 is infinity. What do we get from here? This is 0. When x approaches 0, the limit is infinity. This means that this line, x equals to 0, is a vertical asymptote. And when x approaches 0, the function goes to infinity. Okay, so this is a vertical asymptote. Limit f of x when x approaches negative infinity is 0. Okay, so y equals to 0 is a horizontal asymptote. And this means that if I graph something like this, it would be excellent. It will work. Okay, it will satisfy the conditions. Limit f of x when x approaches infinity is 2. Okay. So also the line, this line, y, you can do it like this. No problem that the graph cuts the horizontal asymptote. We have no problem with that. So y equals to 2 is a horizontal asymptote, and when x approaches infinity, the graph approaches 2. So I can sketch the graph like this. So this graph will satisfy all the conditions, and this is the end of the exam. I hope that you enjoyed practicing this final exam.